Alright, so for problem 1, we're looking at two functions, q of x and r of x. Q of x is equal to 1.05 to the power of x. That's an exponential function. R of x is a linear function, 38x plus 125. We're told that we're only going to look at values, input values of x greater than 0, so we're asked which statement is true. Alright, so we're given a couple options. Q of x is greater than r of x for all values of x. R of x is greater than q of x for all values of x. Q of x is greater than r of x for only large values of x. And r of x is greater than q of x for very large values of x. One thing we have to understand is exponentials grow by multiplication, whereas linear functions grow by addition. So eventually, all quadratics will outgrow linear functions, which means option B, where our linear function is greater all the time, and option D, where our linear function is greater at very large values of x, cannot be true. So we can eliminate those. Now, if we're not sure how they grow, we can always go and select our calculator and just plug in the functions, which is what I'm going to do right now. So I'm going to go type those in here real quick. Alright, so we get the functions typed in, and we see, maybe I'm going to change my graph settings. We're going to start our x-axis at 0, and as I zoom out here, I see that initially, my linear function is greater than my exponential function, but let's just keep zooming out here. And eventually we're going to see that as I zoom out, my exponential is growing faster than my linear function, and eventually we see that the exponential function is greater than the linear function. If you're not sure why that is, let's just zoom in on one of these sections here. Here, the exponential function reaches about 13,000 at 194 for an input, and the exponential function will reach 13,000 when you give it an input of 338. So if I reach it, if a lower input gives me the same value, that means it's a greater function, and therefore as my x values get larger and larger, my exponential will be greater than my linear function. And that answers C. Alright, the graph of a quadratic function f of x has a minimum at -2, -3, and passes through the point 2, 13. The function g of x is represented by the equation g of x is equal to negative x plus 2 times x minus 3. The key thing to remember about this is in g of x, we are given our factored form of the equation, so we know our x-intercepts are solutions. We can just plug this into our calculator. So I'm going to go do that right now. G of x, so I'll put in y is equal to negative x plus 2 times x minus 3. I believe that is the correct equation. And I can just close this box, it'll come back up. Now, if we have a quadratic function and I'm giving you a minimum, in a quadratic function, a minimum is also known as our vertex, which means we can look at our vertex form. We can put our vertex into our vertex form. Our vertex form is oftentimes given by the equation y is equal to x minus h quantity squared plus k. And in this we don't know what h and k are, but we do, because we're told that our vertex is equal to -2, -3. So let's go ahead and substitute -2 in for h. That means we're going to have plus 2 here and minus 3. As we zoom out now, I've got both equations in. I look at my vertex there. That's looking at the wrong point, of course. That's the wrong one. We see our vertex is at -2, 3. It's a minimum for y equals x plus 2 quantity squared minus 3. We see that our other equation has our zeros at -2, 0, and 3, 0. And we look at our y-intercepts. Our y-intercepts for g of x is at 0, 6. our y-intercept, let's close all these other points. Our y-intercepts are at 0, 6, and 0, 1. So our difference in our how much greater is the y-intercept of g of x and f of x is 5. All right, problem number 4. This is just determine what we've done to going from steps 1 to 2 and give a justification for it. So in steps 1, we have 4 times a minus 7 plus 10 times 2a plus 3 is equal to 1. Step 2, we end up with 4a minus 28 plus 20a plus 30 is equal to 1. Well, what we've done here is we've distributed the 4 to the a minus 7 and the 10 to the 2a plus 3. That would be what we call the distributive property. Going from 2 to 3, we see all we've done here is we've changed the position. Instead of going 4a plus negative 28, we have negative 28 plus 4a. We've switched the order. That is the commutative property of addition. A plus b is the same as b plus a. In the third step here, we've taken negative 28 and we put in parentheses around 4a plus 20a plus 30 is equal to 1. We've put parentheses around the 4a plus the 20a. We've associated like terms together. So our step 4, to going from step 3 to step 4, we've done the associative property of addition. Problem 5 is a real simple one. We're told that the model for the bacteria growth in a petri dish after t hours. So t hours, that means t is time. Our input is time. Where t equals 0 represents a time when the bacteria were first put in the dish. So what is the correct value and interpretation of n of 8? Well, the first part is, let's go put this into our calculator. And n of, we basically have 2 to the power of t. In this case, 2 is 8. So we're just going to raise 2 to the power of 8. And we see that's equal to 256. So automatically we know C and D are out because they don't even have 256 as part of the answer. In A, n of 8 is 256. So after 8 hours, there are 256 bacteria. We're told that T, that's what's in parentheses, is hours. So we put T equals 8, so that's 8 hours. A has to be our correct answer. All right, this is one of those equations that is known as the literal equation. We panic and we see no numbers, but it's okay. We see that our potential energy is equal to mass times gravity times the height. So which equation is correctly solved for the height h? Notice you'll see no addition and subtraction signs in the original equation. That means there is no addition or subtraction going on in the original equation, and therefore there probably isn't going to be any in the solution. So it's a good guess that I can eliminate A and B right off the bat, which means I've got C and D. Again, our goal is to isolate H. So let's think about this. If I were to give you a simple equation, like such, let me erase that real quick. Let's try that again. 10 is equal to 2h. How would you solve that? You would divide by 2 on both sides. And you get h is equal to 5. Now, that obviously looks somewhat like our problem. So let's extend it now. P, we'll replace the 10 with P. P is equal to 2h. Again, 2 times h. In the previous problem, we just divided by 2. Division undoes multiplication. And here, we'd cancel out the 2 on this side, and we'd have h solved for itself. Now, what if I did this? Replace the 2 with our m. So now I have P is equal to mh. Oops. Sometimes I don't write very well. Again, just like I did before where I divided both sides by 2, m is being multiplied by h. I divide both sides by m. And I've isolated h again. So we see that P is going to be over m. At this point, we can go back to our solution look at that and see P over M. The G on the bottom there, well, that's just a consequence of this. P is equal to MGH. Well, what did we do to the M? We divided that on both sides. Those canceled out the M. We still have the G. Well, how did we get rid of the 2 or anything else in front of the H? We just divided it out because, again, G times H. So if I divide it, that gets rid of it. And lo and behold, I have P over MG is equal to H. That is this answer right here. All right, which expression is equivalent? So here we have subtraction of polynomials. The big key here is to know that we're going to distribute our negative to each term in the second polynomial. So positive 3r squared becomes minus 3r squared, 4r becomes minus 4r, and negative 5 becomes positive 5. And then you add like terms. That's one way to do it. The second way to do it is enter in the expression as an equation, y equals, and you'll get this. Now when we look at the very first graph here, we see we have a parabola that is opening downward. If we look back at our selections, we see that the first two parabola will open downward because we have negative r squared. For C and D, though, our coefficient is positive, it's 5. Those are going to open upwards, so C and D automatically eliminated. Now let's take a look at our remaining two options. I've typed in the equations of A and B, and I'm going to enable graphing of both of them. When I graph blue, or I select blue, you notice how we see no difference here. So, and then when I select the third option, now I see a second graph appear in green. That does not match up with the red graph, so I know that 3 can't be the correct answer here, or the option C cannot be the correct answer. Y equals negative r squared plus 4r minus 6 is not correct. I'm going to eliminate it. Now, you'll notice now that the graph is in blue. If I were to click this, you'd see it being light blue. I click it, it's a darker blue because they're both aligned. If you still don't believe the results, go ahead and click your gear. And I don't know why it's not giving me the option to put in a table, but it's not right now. That's okay. You see that they're aligned anyways, so you should be fine. Okay, that's how I'd answer this. Then I know it's minus r squared minus 3r plus 4. That's option A. Finally, problem 8, or for this video, problem 8. A system of equations is shown. 4c plus 2d equals 11. 7/2 d is equal to 41 minus 22c. This would be hard to do substitution for because I'd have to multiply both equations, or the second equation, by 2/2, or 2/7, I should say, on both sides to get d, and then substitute that in. I could try to write them both in standard form, multiplying the second equation by 2, and then adding 22c, and then doing elimination that way. But the key is to remember that a system of equations has the same intersection point. And we know that using Desmos, I can type equations in any format I want into Desmos, and it will graph them. So that's what I'm going to do. I've opened up the calculator, and I've typed in both equations. You will notice I changed my variable c to x, my variable d to y, because the calculator will not do this in C and D. It will do it in x and y. I've kept my x and y substitutions consistent. I have an intersection point after I graph both of them, and that answer is 1.45 and 2.6. So x equals 1.45 and y equals 2.6. This is the easiest way to solve the equation, and I would recommend solving a system of equations similarly. Again, you can type them in standard form, slope-intercept form, or any variation thereof. You just are going to need two variables, and then your variables, whatever they've given you, you need to replace with x and y. Again, in this, both times I saw c, I replaced with x, and both these I replaced with y.